ಬಂತು ಬಂತು. ಬಂತು ಬಂತು. Hi guys, good afternoon. So ನಮಸ್ಕಾರ, ಹೇಗಿದ್ದೀರಾ ಎಲ್ಲರೂ? Hope everyone is doing good. So yeah, we'll start the class in 2 minutes. So hope everyone are able to hear my voice. So ಸ್ವಲ್ಪ setup ಏನಿದೆ ಅದೆಲ್ಲ ಮಾಡ್ಕೊಳ್ಳೋಣ. Just give me some 2 minutes of time. Hi guys, so yes, in today's class we'll be learning about whatever we will be learning about electric potential again for system of charges. Then we'll be solving few problems. So as you are able to see in the screen, there are several problems which we are going to check out for today. Then yeah, we'll be finishing this chapter today with problem solving, and yeah, we'll try to complete this. Okay, once we are done, once we are done with this topic, we can start with dipoles and dipole movement for upcoming classes. Okay, so yes, we'll start with the technical check, guys. Hope yeah. So we'll start with the technical check, guys. Please let me know if you are able to hear my voice clearly, and if you are able to see the board properly, and you are able to see my writings also clearly. Like, are able to see whatever I'm able to write? Yes. Okay. So that would be good if yeah. Okay. So guys, yes, am I audible to you guys? So I'm also checking with the YouTubers. Hi YouTubers, good afternoon. So today we'll be we will be learning about electric potential again, a bit of electric potential. So once we start with electric potential, now we'll be discussing about electric potential due to system of charges. Say when we have multiple charges, what is the electric potential? We'll check that, and then we'll proceed with few problem solving. And yeah, once we are ready with everything, and once we are done with this, we'll start with next topic. Okay, cool. Okay guys, cool, awesome. So let's start the class. So people at Zoom, Zoom class, JPMC guys, please try to vote. Please give your response. Please give people at YouTube, please respond with your chat box. Yes, bro. So people in Zoom, please respond with your chat box. People in people in Zoom, use both chat box as well as polls to respond. People in our in YouTube live, please try to respond only in your chat box. Like, yeah, we can, if you have any doubts at any point, you could ask. Okay. Hi Anup. Hi Rahul. Sorry, Rashid. Okay. Hello everyone. Good afternoon. So guys, yes, come on. Let's start our class. So let's revise what we had learned in our previous class. Okay. So, yeah, what did we start with our class? So in the previous class, what did we learn? We learned about, come on guys, you have to tell. So yeah, guys, about the YouTube live, guys, whoever were not able to follow my class in my previous day, you could start. I mean, you could learn. I mean, you could watch the video which is being shared with you in your YouTube live. I mean, YouTube playlist, and yeah, you could check. Okay. So yes, bro. Good. Done. Yeah. So guys, yeah. So I'm going to end this poll of technical check. Hope everyone is able to hear my voice clearly and you are able to see the blackboard clearly. Hi, good afternoon, Shashvita. So yes, guys, come on. Now tell me, what was the expression for external work done? So what was the expression for external work done? So we had learned about expression for external work done. So let's begin our class with that. So the expression for work done was given by Q1 into Q2 divided by 4 pi times of epsilon naught into 1 by R1, sorry, 1 by R2 minus 1 by R1, where R2 is the final position and R1 is my initial position. Okay. So this is the first formula which we learned in our previous day's class. Second thing was in a conservative force. What is a conservative force, guys? What is a conservative force? Come on, reply in chat box. YouTubers, Zoom people, please try to reply. What is a conservative force, guys? Come on, tell me. What do you mean by a conservative force? What do you think a conservative force is? What do you mean by conservative force? Yes, correct, Dikshita. It's independent of path. Independent of path. So here, my electrostatic force was conservative in nature. Was conservative in nature. Right? My electrostatic force was conservative in nature. So if my force is conservative for the external work done, which is being applied, say what was external force applied was nothing but the negative of the electrostatic force, right? Yes, yes. So this force or this work done was a conservative one. So we could write that change in potential energy. Say when if we are moving an object from position B to position A, or position A to position B. Yes, yes, correct, Krish. Correct. Only depends on initial and final position. Say if I'm moving an object or if I'm moving a charge from position A to position B, then the change in potential energy in a conservative nature or when the change in potential energy for conservative force is given as, yes, the external work done, W external, right? Then we learned what was potential. What was potential, guys? What is electric potential? V. The electric potential V is the change in potential energy per unit charge. So we learned this. If change in potential energy is W external, we can write potential energy also as W external by Q. So then next we learned about potential at any point can be defined with taking what as reference. Guys, we also learned this. So we could find the potential of any point. Potential of any point, say I can write it as N with reference to infinity. So that will be becoming W external with reference to infinity by Q, where given that since my potential at infinity will be equals to correct meth. Super you are. So potential at infinity is considered to be 0, right? 0 volts. Then what was the expression? What was the SI unit of potential, guys? What is SI unit of potential we learned? SI unit of potential. Tell me. SI unit of potential or change in potential is given by, yes, volts or joules per coulomb, both. Yes, volts or joules per coulomb. So yeah, for work done we have joules and charge wise we have coulomb. Correct, Sashvita, Prakash, Prajwal, Amit, superb. YouTubers, please try to answer. Yes. So we had learned so much and we had solved few problems. Then we also learned that, okay, this equation, okay, we had tried to express this equation in terms of this. Say if I have a change in position, say if I'm moving my position or if I have change in potential given, if I have the change in potential given, say if VB minus VA is given, then VB minus VA change in potential will also be equals to W external by Q, right? So this change in potential was nothing but change in potential energy per unit charge. So we know that the change in potential energy is external work done, then external work done per unit charge is nothing but my change in potential. So what is the difference between this and this, guys? What is the difference between this and this? What's the difference between this equation, equation 3, equation 4, and equation 5? Are they one and the same or different? Equation 3, 4, 5, guys, which I have written, are they same or different? Are they same or different? Yes, all are same, but here in case of the third case, fourth case, I have taken my infinity as reference, voltage at infinity as reference. So have written V is equals to U by Q, right? Okay, this much we had learned. Now in today's class, we'll be learning about what happens when we have more than two charges. So first we'll learn what happens when we have two charges, okay? Okay, so electric potential due to a system of charge. So what we do, first we'll consider a system of two charges. So let's consider a system of two charges. Say I have a source charge capital Q and a test charge small q. Now guys, what do you think the electrostatic potential, what do you think the electrostatic potential would be, or potential energy for this particular system would be? So guys, if you remember, we discussed that for electric potential to occur, there is compulsory one condition. The compulsory condition was, yes, it always depends, it always exists between two charges. Electric potential always exists between two charges. This was the condition which we had learned, right? Now, what is the electric potential energy given by? So the electric potential energy will be given by, yes, K times Q into Q by R, or say if I'm considering the electric potential energy at point P, if I'm considering, yes, good afternoon. If I'm considering the electric potential at point P, then the electric potential energy, change in electric potential energy with respect to infinity will be UP minus U of infinity is equals to, say, capital Q. What is my capital Q? My source charge times the test charge divided by 4 pi epsilon naught into R, where R is the separation distance between the source charge and the test charge. Then guys, yes, correct Gunashri, superb, awesome. So guys, what will be my potential? What will be my potential? Guys, tell me, what should I do to calculate my potential? If VP is my potential, what should I do? Guys, reply, just one reply. It's a one word answer. Yes, it's a one word answer. Yes. VP is equals to, correct Gunashri, divide by Q, divide UP by Q, the change in potential energy per unit charge. So VP is equals to UP by Q, then that can be written as, yes, if I'm trying to solve, UP by Q, the Q in this term and the numerator and the denominator cancels, I'll get potential at point P is equals to Q by 4 pi epsilon naught into R. Guys, I know, I hope everyone know this. Everyone know this, right? Everyone know this, right? Okay, if you know this, then what happens if I have system of 3-point charges now? Yes, correct. Now tell me, yes, what happens? Correct, Krish. So what happens if I have system of 3 charges? Say I have 3 charges. Say I have charge Q1, source charge Q1, source charge Q2, and a source charge Q3. Now, this source charges are acting on a test charge, small q, at point P. At point P, I have a test charge. Now, these are acting. What happens? What should I do to find electric potential? Guys, give me one line answer. Yes. So, guys, note, in yesterday's class, we discussed that. Okay, tell me, the electric potential V, is it a scalar or a vector? Is it a scalar or vector? Is V a scalar quantity or a vector quantity? Yes, correct, Hariprasad. Guys, remember one thing. In yesterday's class, yes, correct, Prajwal. We had discussed that the electric potential is a scalar quantity. Electric potential is a scalar quantity. Arun, it's a scalar quantity. So it has only magnitude. See, electric potential always have only magnitude. It doesn't have direction. Okay. So electric potential is a scalar quantity and it's always added algebraically, not superposition. So superposition is valid for, guys, superposition is valid for vector quantities. Electric potential has only magnitude. Okay. Hari Prasad, Bhargav, Arun, please correct that. So remember, sometimes maybe they may ask a question like this. They may, I'm not telling they will, they may. Sometimes in any of the state exams or even board exams, they may ask, yeah, electric potential is a scalar quantity. Now, if we are going to add them algebraically, then the potential at Vp will be equals to Vpq1 plus Vpq2 plus Vpq3. Whereas, what is Vpq1, guys? What is Vpq1? It's the electric potential between the source charge Q1 and the test charge small q. Similarly, the electric potential between source charge Q2 and test charge Q is Vpq2, and the electric potential between source charge Q3 and test charge Q will be Vpq3. Now we are going to add all of these. So guys, tell me, please try to type in your chat box, what is the electric potential formula? And try to simplify as much as possible. Yes. What is the expression for? Yes, correct, Rajul. One more in terms of your K, Q, R, in terms of that, Rajul. Right, in terms of K, Q, R. Yes, correct, Shashwita. It is K times capital Q by R, not small q by R. It's always K times capital Q by R. Then we can write the potential Vp is equals to, for Vpq1, Q1 by 4 pi epsilon naught R1. For Vpq2, Q2 by 4 pi epsilon naught R2 plus Q3 by 4 pi epsilon naught R3. This is the expression for Vp, electric potential for system of charges. So guys, what we do? What can we conclude from this? Yes, correct, Bhargav, superb. Correct, Devika. Awesome. Devika Rani, super. So, yeah, guys. So what can we conclude from this? We can conclude whenever we have n number of systems. So whatever the number of charges I have, what I should do? I should always add them, summation of all these charges into K by R. So if I have n number of charges, I have to do n times of these. So if I add all of these charges, I'll get the net potential at that test charge, right? Correct. Okay. Yes. Cool. Okay, guys. So you guys have understood this. Then try to apply the same in the question, in one of the questions here. So what's the question is? Okay, guys. Tell me before we start the question. Tell me if you are clear with all the concepts till now. So we studied about what is electric potential energy, work done, electric potential, and electric potential for system of charges. Say if we have more than 2 charges or more than n number of charges, yeah, what should we do? We had learned that. Correct, Krish? Awesome. Thank you. So yeah, we learned that. Are you clear with this concept? Yes, please reply. Reply if you are clear with this concept. Guys, try to be active, please. Try to be active. Before we start the question, I need, yes. Okay, click on, okay. So from now on, YouTube guys, yeah, you could reply yes. And Zoom guys, you could click on yes. Okay, you have that tick mark, right? You could click on yes. Okay, cool. Thank you. So then guys, try to solve this question. I'm going to give you how much time you require. So this is 1 minute. So I'm going to give you 1 minute. 1 minute is enough, huh? 1 minute is enough now. Okay, try to solve this. So what's given here? So there are 2 point charges, 2 charges. Yes. Awesome, Krish. Superb. So there are two charges. One is plus 10 coulomb, plus 10 microcoulomb, and other is plus 20 microcoulomb. Okay. Now two charges are placed at a separation of 2 centimeters. So it's placed at a separation of 2 centimeters. Okay. Now find the electric potential due to the pair of the charges at the midpoint of the line joining them. So I am exactly finding its midpoint. So at this midpoint, what is the electric potential experienced because of these two charges? Correct, Krish. Awesome. So guys, try to solve this. Come on. Super, Krish. Krish Modi, awesome. Good, very good. So very good, guys. Very good, Shashwita. So guys, come on, try. So I got only one reply in YouTube. Others, hope you guys are getting it. Super, awesome, Amit. Very good. So we'll go step by step, guys. Come on. Just 10 seconds more for 1 minute, guys. Superb, Tejas. Yes, guys, come on. So 1 minute up, guys. So I'm going to end the poll. Shall I end the poll, or you guys want to try more? Okay. So how can we solve this question, guys? Come on, tell me. Hima, check your answer. Hima, Anoop, check your answer. Hima, Anoop, check your answer. Okay, guys. Now tell me what is potential due to 10 microcoulomb charge. Guys, tell me what is potential due to 10 microcoulomb charge. What is the, yes, Bhargav. Bhargav, correct. And Hima, please check your answer. Okay. Yes. Yep. Correct. Correct, Amit. Yes. So first thing is I have to find my R1 and R2. So if this I call this as R1, this I call this as R2, then R1 is equals to 1 centimeter and R2 is also 1 centimeter. Correct. Next, yes, I have to find the potential due to the 10 microcoulomb charge. So V10, I'll call it as V10. What is the expression? What is the formula for potential, guys? Tell me. V is equals to Q by 4 pi epsilon naught into R. So guys, do it. Do it. What is Q by 4 pi epsilon naught? So 4 pi epsilon naught is nothing but 9 into 10 power 9. 1 by 4 pi epsilon naught, sorry, 1 by 4 pi epsilon naught is 9 into 10 power 9. So I'll apply that. 9 into 10 power 9 into, what is Q? Q is 10 into 10 power minus 6 divided by 1 centimeter. 1 centimeter is 10 power minus 2 meters. Okay, what is the answer, guys? What is the answer I get? Just try to simplify this, only the powers. So magnitude wise, it's 9 into 10 power 9 minus 6 is 3. Yes. Nine minus 6 is 3. 10 plus 2 is again 3 plus 3. 10 power 3 into 10 power 3. So I get 9 into 10 power 6 volts. So this is my V1. Come on, guys, tell me. Correct. Yes. Correct, Bhargav. Now tell me, what is V20? V20. Potential due to 20 volts, 20 microcoulomb charge. Yes, again, apply the same formula. 9 to 10 power 9 into 20 into 10 power minus 6 by 10 power minus 2 meters. Correct, Bhargav. Yes, correct, Amit. Correct, Sashwita. So this is 9 into 2, 18 into 10 power 6. I can write directly, na? I can write directly since I have solved my powers for first one. I'll write the second one directly. Okay. Okay. Now. So we told that the potential is a scalar quantity. So if V10 plus V20 will be equals to V net, then what is the form? What is the net potential? So V10 is 9 into 10 power 6 plus 18 into 10 power 6. That will be equals to V net. So what is my V net? V net will be equals to 9 plus 18, 27 into 10 power 6 volts. So guys, option A is the correct answer. V net is 27 megavolts. Okay, mega guys, I hope you know what is mega, what is giga, kilo, milli, tera, pico, etc. Yes, Hari Prasad, the question says we have to find the electric potential at the midpoint. Okay. Hari Prasad, the question is we have to find the potential at midpoint. So at midpoint we have only 1 centimeter distance because of these two. So we are finding it. Okay. Clear, Hari Prasad? Yes. Okay, guys. So I have a question from work done. Okay. Next question is from work done. So try to find the answer. Okay. I hope everyone is clear with this first question, guys. Everyone is clear with the first question. Everyone is clear with the first question, guys. If you reply fast, I can go fast. Yes, cool. Okay. Now, guys, try this question now. Try this question. This is based on work done. Okay. So this is based on work done. Okay, I'm launching the poll again. So this is based on work done. Okay, thank you, Hari Prasad. Thank you for confirmation. Cool. So this is based on work done. So which formula you guys have to use? Try to figure out which formula you are going to use. Tell me which formula you are going to use, then solve. Guys, come on, reply. Reply in the chat box. Which formula, which term are you going to use? So which formula are you going to use here? Or just give me the idea what you are going to do here to solve, how you are going to approach this problem. So there are 3 point charges of 2 into 10 power minus 5 coulomb, 3 into 10 power minus 5 coulomb, and 4 into 10 power minus 5 coulomb. They are to be assembled on the 3 vertices of a triangle. So 3 vertices of a equilateral triangle. So which formula should I use? System of charge. No, Dikshita, maybe, but not exactly that. Guys, okay, try this question. So I'm going to give you 2 minutes. 2 minutes, and 2 minutes is too much, but still I'm giving you 2 minutes. Try to solve this. Okay. So I think I have started the poll, guys. And whoever have answered, I don't know who is this, but please check your answer. Whoever answered the poll, check your answer. Okay. Yes. So I want others to try this problem. So guys, do you want any hint? Ask if you want any hint, I can give you. Krish Modi, yes, maybe, but not exactly. Okay. So this is on work done also. Okay, guys. This is on work done. So how much work has to be done? You have to find how much work has to be done to keep these 3 charges on the 3 vertices. So correct, Tejas. Awesome. Super charges. Yeah, I got 1 correct answer, guys. Krish Modi, check your formula. Okay, guys. So I think 2 minutes have passed. So I'll give you. So guys, say if I have 2 point charges, so I'll give you a hint. I think you with this hint you can solve. Say if I have two charges, 2 point charges. Say I have point A at position A, I have one charge. Yes. At position B, I have another charge. Now these two there is 2 into 10 power minus 5 coulomb here. There is 4 into 10 power minus 5 coulomb here. Now, guys, if I'm moving this charge from here to here, or if I'm moving this charge from here to here, what is, say, both are positive charges again, both are positive charges again, then first, before we define potential, what is the first thing which we want to find? We want to find their potential energy. Okay. So when I move from A to B or B to A, there is some change in potential energy. This change in potential energy for a conservative system is the amount of work done. Yes. Yes, correct, Hari Prasad. Correct, Hari Prasad. Yes, Krish. Yeah, check. So you have to apply the expression, I mean, the equation of potential energy, guys. Try to apply and solve this. Come on. Apply potential energy formula and solve this. Say when we have system of charges, how to find the potential energy. Try to solve this. Yes, those who have done, reply with yes if you have done. Those who have done, click on yes. Guys, those who have done, click on yes, or you can, people in Zoom can vote your answer in poll. People in YouTube Live can vote your answer, I mean, tell your answer. Just reply with your option, A, B, C, or D. Guys, is it difficult? No, right? See. Okay, the formula which I'm going to use is, see, change in potential energy. Yes, change in potential energy is, say, if I have delta U, that is UB minus UA. Okay, this is U, guys. UB minus UA is equals to W external. So they are asking to find only W external. So use this formula, UB minus UA. Or how to find the potential energy between two charges. Say if UAB is the potential energy between two charges, UAB will be equals to K times of Q1, Q2 divided by R12. So this is the formula. If I want to find the potential energy between two charges, then its potential energy is given by UAB equals to K times of Q1, Q2 by R12. Try substitute the values in this formula, guys. Substitute the formula in this, substitute the values in this formula, and you'll get the answer. Done? How many of you did this? How many of you did this? See, the amount of external work done is nothing but the change in potential energy, right? So find the potential energy for considering two charges at a time. Find the potential energy considering two charges at a time. The net potential energy PE, it will be equals to, say if I call these charges 1, 2, and 3. Okay. If I call these charges 1, 2, 3. Now try to apply this. Bindu, no, check your answer. JST, check your answer. Okay, guys, come on, I'll solve for you. So U12 plus U23 plus U13. Okay. So consider two charges at a time. Consider any two charges at a time and solve that. So total net potential energy is nothing but the external work done. So how much potential energy I'm applying, that much amount of work done. So how much potential energy these charges are giving me, that much amount of work has to be done on them. Okay, that was the formula which we had learned. This is a conservative force acting between the charges. There is no external force acting on them. So the change in potential energy or total potential energy will be equals to the total work done, right? So guys, I'll directly substitute. Okay, what are the common things here in all three charges? What are the common things in all three charges? When I'm finding UAB, the common thing is K, and one more common thing is 10 power minus 5 in all cases, right? 10 power minus 5 into 10 power minus 5. So because I'm multiplying two charges, each charge has 10 power minus 5 coulomb. So I'll take 10 power minus 5 as common for, 10 power minus 5 into 10 power minus 5 common for both. Yes, divided by. So what is again one more thing common, guys, in all three cases? My distance between the 2 points in any case will be 10 centimeter only, because it's an equilateral triangle. Yes, correct. Oh yeah, R is also same, correct, Tejas. So 10 power 10 centimeter means 10 into 10 power minus 2. So these things will be same for all. Same for all. Yes, Prakash, correct. Then find potential energy, guys. ನೋಡಿ ಎಲ್ಲ ಹೇಳಾದ್ಮೇಲೂ ಮಾಡಿಲ್ಲ ಅಂದ್ರೆ ಹೆಂಗೆ? So the potential energy, total potential energy, that is the total work done, work external to be applied is change in potential energy, that is U12 plus U23 plus U13. So there in all these cases one thing is common, K into 10 power minus 5 will become 10 power minus 10 divided by 10 into 10 power minus 2 will be 10 power minus 1, right? Into, now just multiply the charges, U12, 1 and 2. So 4 into 2, right? U12 will be 4 into 2 plus, what is U23, guys? What is U23? U23, 2 into 3, right? Plus 2 into 3 plus, what is U13? 4 into 3. Okay. Now, so substitute everything. So you'll get K values 9 into 10 power 9 into 10 power minus 10 into 10 power plus 1 into 4 to the 8 plus 2 3 is 6 plus 4 3 is 12. So 9 into, see, I have 9 plus 1 10 minus 10 cancels, everything cancels here. 9 plus 1 10, 10 minus 10 is 0. So my power gets cancelled, correct Bindu, correct Bhargav. So 9 into 8 plus 6 plus 9. 6, 6, 12, 13, 14, 14, 26, right? Yeah, 26. So this will be equals to 54 plus 18 plus 5, 23, 234 joules. Yes, guys. So my external work done, W external will be equals to 234 joules. 234 joules. Hope everyone have got this. Hope everyone have got this. Yes. So majority of you had given this answer, but there are some people who have not at all answered. Guys, come on, Bunny, early, early. So guys, I hope everyone have understood this question. Everyone have understood this question. Please click on S if you have understood. YouTubers, please reply with S if you have understood this question. See, this was work done. The net work done is change in potential energy or the total potential energy of these three charges acting on each other. So if I add the potential energy, I'll get the external work done. Yes, I did that. So the work external will be 234 joules, 234 joules. Awesome, guys. Thank you. Thanks for the response. Come on, guys. If you have understood this, then this question should be easy for you. Okay. Now try this question. Okay. Try this question. So try this question. There are three identical charges placed at the corners of an equilateral triangle. Again, we have an equilateral triangle. Draw an equilateral triangle. Okay. Equilateral triangle of side length L. So the side length of the equilateral triangle is L. If the magnitude of force between any two charges F. So I have, okay, three charges. Okay, I'll use a different color for this. So I have three charges, 1, 2, and 3. The magnitude of charges, the magnitude of force between each charge is F. So if these two charges are interacting, it's F. If these two charges are interacting, it's F. And if these two charges are interacting, F again. Yeah. So then the work required to double dimension. So here, what are they asking? Say if the force between any two charges F, okay. Now if I have to move these charges, in this direction such that I'll get a bigger triangle. I'll get a bigger triangle of length. Okay, I have to move in this direction such that I'll get a bigger triangle of 2L, length 2L. So what should be my work done? What should be my work done? Okay, try to answer this, guys. Okay, thank you, guys. Thanks for your response. Come on, guys. Bindu, check your answer. Bindu, we check your answer. Correct, Prakash. Prakash Godas. Prakash Goda, please. Magnitude wise fine. Check again. Prakash Goda, magnitude wise fine, but check again. So this question is kind of lengthy derivation, but it's simple, okay now? Like, yes, Prakash Goda, correct. So guys, so I'll give you a brief idea of what to do in this question. See, first they have given force. What is force? The force between two charges is F, okay now? Now, if the force, so they have also mentioned all the charges are same. Three identical charges. They have mentioned three identical charges. All the charges are of same value, Q, Q, and Q. Okay. Now, if all the forces are of same value, then what is the force between two charges given by Namrata? Yes, magnitude wise correct, but sign wise wrong. Dikshita, magnitude wise correct, sign wise wrong. Meghana, Mega SP, awesome, you are superb. Mega correct, Namrata correct. But guys, whoever I said magnitude wise correct, please check your sign where you went wrong. Okay, maybe in the LCM you might have taken something wrong. Okay, so did I give enough? Yes. So guys, I have given 3 minutes plus. Dikshita, check again. Hari Prasad, yes. Magnitude wise correct, sign wise check again. Krish correct. Krish Modi, awesome, you are awesome. Ramakrishna Reddy correct. Radhika correct. Yes, guys. Superb. Okay. So first find what is the force, guys. Now tell me what is the force, expression for force. So we learned expression for force as K Q1 into Q2 by R square, where R is my L. Initially, my length is L square. So if I want to write it in proper way, it's nothing but, yes, the force F is 1 by Q1 into Q2 by 4 pi epsilon naught into L. Right? Sorry, L square. It's L square. Now, what is my initial potential energy between any two charges, guys? If there are two charges acting, what is my initial potential energy? What is my potential energy? What is potential energy? Expression for potential energy. Someone reply in chat box. Expression for potential energy. Okay, everyone try to reply in chat box. What is potential energy formula? Correct, Dikshita. Superb. Correct. Superb. You are giving awesome response, guys. I'm very happy you are giving good response today. So please keep the same mode always. Okay. So the potential energy is given by K times Q by L, right? For any two charges, it's for any charge, it's given by KQ times of L. It's the electric potential, right? So it should be KQ into Q by L, right? Electric potential energy. I'm asking for potential energy, guys, not potential. Potential energy. Okay. Sorry, did I say? Yeah, it should be potential energy. Yes, correct. Correct, Hari Prasad. Hari Prasad, you are superb. Come on. So if this is the expression for electric potential, so this is general expression, guys. This is general expression. For this question, what should be the electric potential? Tell me. Tejas, no. Check your answer. For this question, what should be my potential energy? For this question, tell me what should be my potential energy. Guys, reply. Potential energy, Dikshita. I'm asking initial potential energy, okay? Not final potential energy, initial potential energy. My initial potential energy will be, yes, correct, guys. Correct, Shashwita, thank you. Shashwita, correct. It is K times Q1 into Q2. My Q1 is Q, my Q2 is also Q, and my initial separation is L. So K Q1 Q2 by L. So this is for first pair. This is for, if I consider this side as first pair, this is for first pair. Similarly, how many pairs I have? I have 3 pairs of charge. So it will be KQ into Q by L plus KQ into Q by L. Why? How many sides I have? 1 pair, 2 pair, and 3 pairs. I have 3 pairs. Yes, correct, Bhargava. Bhargav, superb. You are correct. Yes. So this is my initial potential energy. What is, yeah. What is the magnitude finally, guys? Initial potential energy magnitude enta? So it's 3 times of K Q into Q by L, right? Yes. Now tell me, what is my final potential energy? So when I move, see, whenever they ask you to find the work, what you do, you check what is the potential energy. The change in potential energy is enough. Okay. So U final, for final position, all will be separated by a distance of 2L. Correct, Ramakrishna? Awesome. Ramakrishna ready, correct. And someone had given me this answer already. Who was that? Dikshita, I think you had given this answer. Yes, correct, Dikshita. Super. So it's K Q1 to Q2. See, the charge is not changing, it's remaining same, but only my distance is changing. Correct, Tejas. Superb. Tejas, correct answer. So this is my final potential energy. This is nothing but 3 by 2 into KQ into Q by L. Okay. So I have taken the 2 outside. So I have written like this. Now, what is the change in potential energy, guys? I know what is my expression for work done. Work done is nothing but change in potential energy. Change in potential energy. What is change in potential energy, guys? What is change in potential energy? Say W external is change in potential energy is final potential energy minus initial potential energy. Aitam? Yes? Okay. Try to find the change in potential energy. W external is equals to, what is my U final? 3 by 2 into K times Q into Q by L minus K times Q into Q by L into 3. So what is common here? KQQ by L is common into 3 by 2 minus 3. Solve this. Solve this. What will we get? Yes, correct, Ramakrishna Reddy. Hari Prasad, correct. So my W external will be equals to, yes, simplify this LCM. Guys, 3 by 2 minus 3 will be 3 minus 6 by 2. That is minus 3 by 2. Okay. So that is minus 3 by 2 times KQ square or K into Q. Yeah. KQ square by L. So guys, if you remember, what is my force? What is my force? It's nothing but KQ square by L, right? So I have to write expression for work done in terms of force. That is 3 by 2 times F by C. If this is F, I have, so my, none of the answers are matching here, right? See, 3 by 2 F will be my answer, but none of the answers are matching. So what I'll do? I'll divide and multiply by L, okay? See, if I want to, okay, again, if I want to get L, I want to do, okay, if I want to write it this as F, I have to multiply and divide by L. Why? I should have L square in the denominator, right? Yes, correct, Hari Prasad, superb. So my final answer will be 3 by 2 F into L. So option C is my correct answer. Option C is my correct answer. How many of you gave this? Okay, very less members. I mean, 6 people had given. So hope everyone is clear now. Everyone is clear now. Yes, correct, Hari Prasad. Thank you. KQ square by L square. Okay, KQ square by L is work done. So I'm doing one more additional thing here. I'm dividing and multiplying by L. So when I do this, I'll get KQ square by L square. Then I can write it as F into L. So I get my question answer. Okay, guys, click on yes if you have understood. Yes. Shall I move on? Move on. Yes, let's move on. So one more similar type question, guys. One more similar type question. So I had a similar type question at one side. So try to solve this very quickly. So you should not take more than you have solved a question similar to this. So you should not take more than 1 minute. Even 1 minute is too much, no? So we have three particles, each have a charge of 10 microcoulomb, are placed at the three vertices of an equilateral triangle of side 10 centimeters. Guys, you know what is the equation in the previous question only. Now try to apply that and find the answer. That's it. So you know how to find it. In previous two questions you had tried. So in one of them, so which one will you apply, guys? Tell me. Yes, correct. Whoever answered this is correct answer in the polls. Whoever answered in the poll, that was correct. Awesome. Come on, guys. Superb. Super, guys. YouTubers, try to answer, please. Hope everyone is getting this. So which formula? Someone tell me which formula am I going to use here? Help me solve, please. Which formula am I going to use here? Correct, Ramakrishna Reddy. Awesome. So you could use any of these, like, yes. Krish Modi, correct. Okay. So yeah, correct, Dikshita. So we are going to use which answer, which formula? Yes, correct, Mega SP, superb, awesome, correct. Yes. So the expression which we are going to use is W external equals to, say, work done by a person in pulling them apart to infinite separations very slowly will be equals to. So what is my work done, guys? Conservative force. My work done is always the change in potential energy, right? Or net potential energy. We can say the net potential energy. What is the net potential energy here? So we'll be finding the net potential energy. Use this one, only this. Okay. Try to answer. Yes, correct, Tejas. Yes, Hari Prasad. Your answer was correct for previous question. Thanks for the confirmation. So others, try to answer, guys. Yes, Dikshita, correct, superb. Okay, so I'm going to end the poll. Guys, try to reply. Okay, I'm going to end the poll. Correct, Prajwal. Prajwal, correct. Guys, if you are not, if you are answering in the chat box and not answering the poll, please note that you have to answer in both poll. I mean, your answer only in the poll will be counted, not in the chat box. No? Okay, thank you, guys. So, guys, that's all. Let's quickly end this. That yeah, U12. What is U12, guys? What will be my U12? See, since my force, I mean, since my charges are same, can I write it? So, what is my general expression for U? U is K Q square by R. Can I write this? So, if this is my general expression for U, and if my Q value is same for all, and R value is also same for all, then can I write U12 plus U13 plus U23 as 3 times of U? See, in question they have given same charge, same distance. All three particles have same charge and same distance. And I know the electric potential energy is kq square by r. Then if U is equal to kq square by r, then work external will be equal to 3 times of U. Can I write this? Yes. Then find W external. Yes, connect Hima. Hima, correct. So 3 into 9 into 10 power 9. I'm directly substituting everything. 3 into 9 into 10 power 9 into what is Q? 10 into 10 power minus 6 whole square divided by 10 into 10 power minus 2. Simplify this, guys. You'll get the answer. So 3 9s are 27. So you got the magnitude. 27 into, again, everything else is simplification. So 10 power 9 into 100 into 10 power minus 12 is 10 power 10. 10 power minus 10, this one is 10 power minus 10. From denominator, I get 10 into 10 power minus 2, that is 10 power plus 1. Then I take it to numerator. From here, these values are going to cancel. So my work external, W external will be equals to 27 joules only. Okay, 27 joules only. Yes. Correct, Jayashree. Jayashree correct. Hima correct. Shashwita correct. Super. So, yeah. Okay, let's go to next part. Then, guys, let's go to next part. So, in next part, we'll be deriving an expression for or we'll be checking what's the relation between my electric potential and my electric field. Okay. What is the relation between electric potential and electric field? Okay. In this part, what we will be doing, so let us consider an electric field. So I have an uniform electric field. So this is a uniform electric field. In this uniform electric field, I have a source, I have a test charge. I have a test charge, small q. Now guys, if there is no external force acting on q, in which direction will my q go? Along E or perpendicular to E or parallel to E in the opposite direction or in the same direction with E? Okay, Jayashree. Cool. So in which direction will my charge Q, test charge Q would go if there is only electric field and no other path? I mean, no other force acting on it, and it's not moving in any other direction. So in which direction it would have gone, or what would be the force experienced by it? What would be the force experienced by my charge, test charge, in an electric field? Tell me, guys. No, not perpendicular, Jayashree, no. Say we had learned Fe is equals to Q times of E. Remember this? So what happens? My Q, if there is no other force acting on it, or if it's not going in any other direction, it will go along with my electric field in the same direction as of electric field, right? So only the electric field has a direction, Q had only the magnitude. So my Q, the force experienced by Q will be along the direction of electric field, guys. Correct, Shashwita. Shashwita, correct. So now the force experienced by charge Q is F is equals to QE that we saw now. Then if what's happening here, in this case, my charge is not going in this direction. Instead, it's making an angle theta with respect to the electric field, or with respect to horizontal, and it's moving in a particular direction, making an angle theta. Okay. So here in this case, my charge is moving in this direction, making an angle theta. Okay. Now what happens? What happens if my charge moves a bit? My charge is moving a bit. So it's covering a small distance dr. It's covering a small distance dr. Now, what would happen to its potential energy? Guys, tell me what will happen to its potential energy? So electric potential. So okay, now tell me what will be its electric potential energy, or what will be its electric potential? Guys, I'm waiting for you guys to respond. Tell me first. What do you think its electric potential energy would be? Say, what's happening here? I have a charge Q. If there is no any external force acting, my charge Q would move in the same direction as that of electric field. But now what's happening? My charge Q has changed its direction. It's moving with an angle theta with respect to the horizontal. Okay. Say, suppose this happens, my charge Q travels a distance of dr. Now, what will be its electric potential? Girish. Okay, Girish, we but gave an answer. Nice. So guys, the electric potential experienced by the charge will be given by dV is equals to, so we learned this right in our previous class. We learned the change in potential is nothing but external work done per unit charge, right? dV is equals to dV is equals to W external by Q. Now, okay, if I want to find, see guys, we know dV is equals to W external by Q. Now we have to find what is dV. So what is my W external? Yes, correct, potential decrease. Cool. So what will be my work done, guys? External work done will be equals to, so we know my external work done is nothing but force into displacement. Force into displacement. So what is my force? The force experienced by charge is Q into E. The small displacement it takes is small d into R. So it moves in this direction with the displacement of dr, experiencing a force of Q into E. Now, my change in potential, yes, correct guys. The change in potential is given by minus Q into E dot dr by Q. Okay, what will we get from here? What is the relation we get from here? Yes, correct, Jayashree. What is the relation we get from here? So we get a relation between the electric field and the electric potential as my electric field dV is equals to minus of E dot dr. So thanks, Girish. Yes, thanks for your response. Yes, thanks, Jayashree. Thanks for your response. So Girish, correct. So my change in potential energy. So guys, in which direction was my force external? Why is there a negative sign here? Why is there a negative sign here? From where did we get the negative sign? Why is there a negative sign here? Yes, in the direction of electric field. Okay, or my electric potential is in the direction of. Okay, we'll come to that conclusions. Okay, so I got this negative sign. How we know when we are applying external work done, when we are doing some external work, the force applied, the force external was nothing but minus of Fe, right? My force I applied was minus of Fe. From there we got minus of Fe, that is minus Q into E dot dr. From here we get an expression, my Q and Q cancels, dV is equals to minus E dot dr. Again guys, yes, correct, opposite direction, correct Fish Modi. So guys, dot product A dot B is, what is A dot B? What is A dot B? A dot B is AB cos theta, right? I hope everyone remembers this. A dot B is equals to AB cos theta. From here, applying this to this, vector E dot dr will give me E cos theta, right? From here, E cos theta, if I want to find only the electric field, see, I wanted to find the relation between electric field and potential now. So E cos theta will be equals to dV by dr, or E cos theta will be equals to minus differentiation of V with respect to R, dV by dr. So if I want to find, or we can write dV. Yeah. So, okay, Girish, you can get from here, okay. So dV, if I want to write for dV is equals to minus E dot dr, right? If I want to find only dV, if I want to find V from here, guys, if I want to find V from here, what should I do? Tell me, what should I do? You guys are learning maths now. If I want to find V instead of dV, I want to find V. Yes, correct, Sashvita. So we have to integrate on both sides. Integrate on both sides. So on integration, yes, we get V is equals to, from here, integrating integral of d into dV will be equals to V equals to, my electric field here is uniform or constant. So my electric field comes out minus E times integral of dr. So what will you get, guys? Integral of dr. What is integral of some function? Integral of a variable dr. What is the integral of variable dr? It's the same function, right? So from here I get V is equals to minus E dot R. So this is also an expression for, or the relation between electric potential and electric field. Okay. So my SI unit for electric field can also become as E is equals to dV by dr, that is my SI unit for electric field. This is for electric field SI unit derived can be volts per meter also. Okay. Hope you got the derivation, guys. Click on yes if you have got the derivation. So we derived an expression for electric potential using, or derived a relation between electric potential and electric field. Yes. Okay, thanks for the confirmation, guys. So remember this. See, you have to remember this box. Just remember this box. dV is equals to minus E dot dr, or E cos theta is equals to minus dV by dr, or one more, V is equals to E minus E integral dr also. Okay. So yes, then this was my relation between electric field and electric potential. Now we have several conditions. Okay. So first condition is, if my theta is equals to 0 degree, what happens? Guys, I want you guys to answer this. If my theta is equals to 0 degree, so what happens here? So what is theta, guys? What is theta first? What is theta? What is theta? Yes, correct, Prakash. Thank you. So first tell me, what is theta? So what was theta here? It was my angle between my Q's direction and my electric field direction. Angle between my electric field and the Q is given by theta. It's the angle between. Yes. Okay. Now we know if my theta is equal to 0 degree, then I can say the voltage, the electric potential is in the direction of electric field, right? If my Q in that equation, say if this is my electric field, okay, I'll try to draw a neat one. So if I had some electric field E, and if my charge is going in this direction, if my charge is in this direction, then this angle was theta. Say if theta was 0 degree, my charge would go in the same direction as that of electric field, right? In that case, if I apply cos theta is equal to 0 in this function, what would I get? Yes, E is equals to minus dV by dr. So overall, this expression, say I would get from here minus dV is equals to E dot dr. From here, I would get my dV is negative. My dV is a negative value, right? What does my dV negative value mean? So this means that the direction of electric field, guys, this is very important observation. My direction of electric field is always from higher potential region to a lower potential region. See, my electric field always, or my electric charge always move from higher potential region to a lower potential region. See, even this is same in case of current also. My current flows in the direction. What is current, guys? Current is nothing but flow of charges, right? Correct. So if current is the flow of charges, then my flow of charge, or whenever my flow of charge occurs, or whenever there is charge present, there is electric field present. So my electric field direction is always from higher potential region to lower potential region. Please make a note of this. This is very, very important. Okay. Yes. Then, or we can give one more conclusion, that in the direction of electric field, other conclusion we get is in the direction of electric field, my electric potential decreases. In the direction of electric field, my electric potential decreases. How can you remember this, guys? How to remember? How to remember? Yes. How to remember this? Say in our home, we have a overhead tank, right? We have this syntax. I mean, if you guys remember, there is some syntax tank. Okay, and there are pipes coming out of it, and it runs all the way to the tap. Say if we have a tap at our home end, we have a tap. So my syntax is always kept at which potential? Always kept at a height, right? So my syntax or the tank is always kept at higher potential, right? And the bucket which we keep, or the vessel which we keep, is at lower potential. So if charges are my water, if water is my charge, then my water or the electric field. If I consider water as my electric field, if I consider water as electric field, then my water flows from a region of higher potential region to lower potential region. Similarly, my electric field is also in the direction of higher potential region to a lower potential. Okay, this way you can remember. Or say one more thing where we apply is, say when I'm trying to bring a charge, when I'm trying to move a charge, so electrically we can remember like this: when I'm trying to move a charge in the direction of electric field, how much work should I do? The amount of work done by me is minimum, right? So my potential also decreases. Yes, Shashwita. Shashwita, ask your doubt, please. Shashwita, ask your doubt, please. See, when my charge is in the electric field, when my charge is in the electric field, it moves in the presence of an electric field. It moves in the same direction. At this time, I don't have to do any work to make the charge move. But suppose if I'm moving the charge against the electric field, if I'm moving the charge against the electric field, I have to do lots of work. This work will be saved inside the charge, will be stored inside the charge as potential energy, and potential energy per unit charge will be given as my potential. So what can we conclude from here? Along the direction of electric field, my potential decreases. My potential decreases. Against the direction of my electric field, my potential increases. Okay. Remember this. Along the direction of electric field, my potential decreases. And against the direction of electric field, my potential increases. Okay. Okay, guys, come on. So if you have you guys understood this? Understood the relation? So just simply remember this box. That's enough. That's more than enough. dV is equals to minus E dot dr, or E is equals to minus dV by dr. Okay. Just remember this. E dot dr is equals to minus dV, or dV is equals to minus E dot dr. Yes, if you are clear with this, try to apply this formula here, guys. So what's given here? Yeah. So try to apply that in this question. Okay. Try to apply that. So what we have here is an electric field E. I have an electric field E whose magnitude is given as E is equals to 20 I cap plus 30 J cap newtons per coulomb. Exists in the space. If the potential at origin is taken as 0, find the potential at V at 2, 2. So how can I write this 2, 2, guys? How can I write this 2, 2? This is nothing but 2 I cap plus 2 J cap. Can I write like this? Can I write like this? Yes. So V at 2, 2, this is nothing but my R. Okay. This is nothing but my R. This is nothing but my distance. At this location I have to find. So I'll consider this as meters. 2 I cap plus 2 J cap meters. Now try to solve this, guys. Try to solve this question. Okay. So try to solve this question. Meanwhile, I'll post you this. Please take the survey for you guys, so it helps us. Yes, correct, Hari Prasad. Cool, nice. Then try to apply this now. Try to apply find V at okay. What you have to do? To find V at 2, 2 at my location 2, 2. Yes. So yep, I have received answers. Correct, Devikarani, Ramakrishna Reddy, and Krishmoji, Jayashree. All correct. All are correct. Which product? I mean, what is the thing we have to use here? So guys, one thing you have to remember here is A dot B. Say A dot B. What is A dot B? Say if A is equals to Xi cap plus Yj cap, and B is nothing but say A, not A, I'll use something else, some other variable. P. You can use P. Pi cap plus Qj cap. Then A dot B will be equals to C. X into P plus into Q. Now guys, I'm not going into the detail of this. Not going into the detail of this. Okay. Yes. Acha, ठीक है. Thank you, Jaya. That's correct. Okay. So yes, Nitya, Megha, Rajwal, correct. Shashwita, correct. So I can launch the poll if you have done this. Correct, Prakash. Correct, Arun. So meanwhile, you could reply me in the chat box only, everyone. Correct, Jayashree. Yes. So let me start solving this then. So guys, what we had to find? We had to find V. What is V? So I know dV is equals to minus E dot dr. Right? I know dV is equals to minus E dot dr. This is very simple now. So I have to take E. What is E? 20 I cap plus 30 j cap. Whole, there is minus here. Product of dot product of 2 I cap plus 2 j cap. That's it. There is nothing much here. So that is 20 into 2, 40 I cap plus 13 into 2, 60 j cap. Oh, sorry. I into I is 1 and j into j is 1, right? So we won't get I cap and j cap again. I get only 13 to 40 minus of 60 plus 40, that is minus of 100 volts. So this will be my V. This will be my V. So option A is the correct answer. Okay, done. Yes, correct, Prajwal. So yes, guys, you can take this question as homework. Try to take okay, this question as homework. Please take a screenshot of this. If you're using phone, you can take a screenshot of this. Anyway, I'll be sharing this in your notes. I'll be sharing your notes also. So take this question as homework and try to solve, okay? So just take it as homework. Okay, did someone get the answer now? I think you can solve now also. I think you can solve now also. So again, same formula applies here too. There is uniform electric field in positive x direction. If the work done on moving a charge of minus 2 coulombs through a distance of 2 meters, moving a charge of 0.2 coulomb, not minus 2, it's 0.2 coulomb to a distance of 2 meters along the line making an angle 60 degree with positive x-axis is 4 joules. So they have given the work done for moving the charge and they have given the angle. What is the magnitude of electric field, guys? So directly simply apply this formula. E cos theta will be equals to minus dV by dr. Apply this, you will get the answer. Can anyone solve now and tell me what's the answer? Anyone solve now and tell this answer? Someone solve now and tell the answer for this. I mean, I want everyone to solve now, not someone. Everyone solve now and tell this answer. E cos theta. So what is cos 60? So we have to find E here. What is E? Hari Prasad, check cos 60. What is cos 60? Yes, correct, Shashwita. Yes, correct, Krishna. Krish Modi, right. Krish Modi, once check the man to Krish Modi, your answer check once. Yes, Prajwal, superb. Namrata, correct. Okay, guys, so we have to find E. So I'll take E is equals to minus. Okay, we'll write E is equals to minus dV by dr, or instead of this, I'll take E is equals to, what is V? Is my V given? Okay, I can okay, I have to do this integration, no? I'll take E dot dr is equals to minus dV. From here, integrate on both sides. So dV is equals to minus E dot dr. Integrating on both sides, I would get V is equals to minus E dot R. Okay, just this one, this formula only. Apply here. What is my V? Again, guys, what is my V? How can I use this? Which formula should I use? So I should use W by Q. Sorry, yeah. Sorry. Then they have given work done, right? So what is based on the given data, we have to take the variables. So they have given work done. Note that they had given work done. W is equal to 4 joules. Then they had given charge. So Q is 0.2 coulombs. Am I right? Yes. So from here, what I know, we know V is equals to W by Q. Guys, remember this. We know V is equals to W by Q, right? And also we know W is equals to force into displacement. Work done is force into displacement. Now use these two to find. Okay, now use these two to find. Yep. So is my D variable, which is my variable? Actually, this is not a cross product. This should be a dot product. I can't write cross product everywhere. It's a dot product. Okay. Try to solve this, guys. Then my W can be written as W is equals to integral F dot ds. So try to solve this. I get W is equals to F into S cos theta, right? F into S cos theta. So integral F is constant. Since my force is constant, it comes out. My displacement is the one which is changing. So F into S cos theta, it's varying with respect to theta. So from here, yeah, what is my E? So yet this is nothing but F is Q into E, Q times of E cos theta into S cos theta, right? From here, I'll get E is equals to W by Q into S cos theta. Not this, not both. ಸಾಲ್ವ್ ಮಾಡಿ ಸಾಕು ಇದು ಮುಗಿಸಿ 4 by Q ಅಂತ 0.2 into S ಅಂತ 2 into cos theta ಅಂತ 1/2. ಸೊ ಹಾಕೊಂತ ಬಂದರೆ 4/0.2 ಸಿಗುತ್ತೆ. ಎಷ್ಟು ಬರುತ್ತೆ? ಹೌದು. Yes. Data. Oh shit. I'm talking in Kannada. I'm not Okay, guys. So hope everyone have solved. Correct, Dikshita, Prajwal, Megha, Namrata. Everyone have tried. YouTube guys, try to reply no. YouTube people, please try to reply. So if you try to solve this, you will get 20 joules. Okay. So there was minus sign somewhere. Was there any minus sign? No. It's 20. Okay, I'll take only the magnitude 20 newtons per coulomb. Okay. Understood, guys? Yes, correct. Jay Shri Bhargav, correct. Hari Prasad, confirm for your confirmation. That is cos 60 degrees, not root 3 by 2. It's only 1 by 2. Okay. Cos 60 degrees, 1 by 2 only. Okay. Sin 60 is root 3 by 2. Cos 60 is 1 by 2. Okay, guys. Then I hope everyone learned something new today or learned something today. And I hope your class went well. Then we'll meet tomorrow. So I have to end this class. Then we'll meet tomorrow. Okay. Okay, guys. Then see you. Bye bye. So bye, YouTubers. Okay. Cool. And then okay, thank you. Then see you guys. So I'm going to end this chat for YouTubers and everyone. Yeah, guys. Bye. So I'll give you some